Hello Year 10. I set you a task on Hegarty a few days ago. Some of you did really well on it. Some of you struggled a little bit. Understandable really, because we hadn't actually done this particular technique in class. It was about, you had to find the areas from triangles, but you had to use trigonometry to do it. So I'm going to show you the kind of thing, as an introduction, the kind of thing you need to be able to do. Okay, we're going to start with some simple areas of triangles. So this one, for instance, dead easy. You've got a perpendicular height 6, base is 10. So obviously you're going to do 6 times 10, half it, and you're going to get 30 centimeters squared for that one. That's easy. This one again, you've got your perpendicular height, you've got your base of 12, so 48 divided by 2, 24 centimeters squared. This one again, you've got the perpendicular height is 12, but it's inside the triangle. That's no problem. Times by 20. I'll tell you what, if we just do that, there you go, you see, it's perpendicular. So 12 times 20, then half it, well, I might as well just half the 20. So 12 times 10, which is 120 centimeters squared. And then we move on to this one down here. As you can see, it's a little bit different. There's no height. There's no perpendicular height. Got the base. The base is 15. Okay. And we've got an angle that we didn't have over here because we didn't need an angle for those, but that might come in handy. Right. So is there a way of working out the height? Well, of course there is. Otherwise, I wouldn't be showing you. So here we are. What I've done is I've taken this triangle on the left, this right angle part of it, and put it there. Again, I don't know the base. It isn't 15 because 15 is all the way across. I don't know what that is, but I do know that's 10. I know that's the height, well, h, and I know that this angle here, more importantly, is 30 degrees. Okay, so what I know in terms of trigonometry, well, first of all, we're not going to use Pythagoras. Okay. You might think, well, there's two sides there, so we just find a third side. No, because this is not in itself a right angle triangle. Okay, so we'll use this part, which is right angled, because we've got a right angle there. Okay, so besides Pythagoras, I've got sine, cosine, tangent. So let me just label my triangle first. I've got 30 degrees, that must be the opposite. That must be my hypotenuse across from the right angle. And this one down here that I'm not going to use is the adjacent. I don't know what it is. It's not what I'm interested in working out, so I'll leave that. So it's these two. Opposite and the hypotenuse is sine. So I'm going to write here that sine 30 degrees equals opposite over hypotenuse h over 10. All right. I want to work out what h is, so I'm going to do some rearranging. I'm going to use some algebraic manipulation. I'm going to multiply both sides by 10. Those two will cancel out, which is what I want to happen. And so I know that basically 10 times sine 30 degrees equals h. Now I happen to know, and maybe you might remember this from a week ago or so, sine 30 is 0.5. It's a half. So essentially that is 10 times 0.5, which equals h. So h must be 5 centimeters. So now I can use that back in here. So I know the height is 5, so essentially it's 5 times 15, the base, divided by 2. 75 divided by 2 is 37.5 centimeters squared. All right. Right, hopefully you're okay with that. Let's just move on and try it, just to make sure it's not a fluke. Let's try it with this one, okay? Same thing. That's the whole base all the way across, that 18. And again, what I've done is taken this left hand part and put it there, and yes, I've got a right angle. Okay, Again, I don't know what that is, no idea. But if I look, I've got 50 degrees, I've got an angle, so I'm going to use my trigonometry again. So label the sides, that's the opposite, sorry, as it was before. That's the hypotenuse, the adjacent again, I'm not going to use that. It's a bit redundant. So what I'm going to write here is sine 50 degrees equals h over 12. And again, I'm going to do some manipulation here. It's going to multiply both sides by 12. They will cancel out. And so I have 12 lots of sine 50 degrees equals h. Now at the moment I'm going to keep that as one value. Okay, I'm not going to work it out there. I'm going to put it back over here. That's my height, remember. That's the height. So height times base, isn't it? Or base times height. So I'm going to do 18 times 12 sine 50 degrees. Oops. Bit messy. Divided by 2. And that will give me the area. Okay, 18 times 12 sine 50 degrees divided by 2. I'm not going to work it out. I'll leave that for you. All right, you can have a go at that one. So is there a general formula we can use? Well, first of all, you probably noticed we tend to be using the sine ratio, and that's why at the top it says using the sine for areas of triangles. Okay, so let's see if we can get some general formula for this, or at least one version of it. Okay, so here we go. So just a general triangle. First of all, you've got to get used to labeling your triangles like this. If you're doing sine rule, cosine rule in future, you tend to use little letters for your sides and the capital letters for your angles. And the way you tend to do it is angle C will be opposite length C. All right. I know it's not on here, but angle, so length A will be across from angle A. And that's how you label it. All right. So let's see if we can work out what H is going to be in terms of all these letters. So we know that sine, so just take this right angle part here, okay, just on the left. We know that sine C is opposite over hypotenuse H over A. And what I've been doing, which is what I did over here, I'm going to multiply both sides by A, whatever A is. Just do that, and then those will cancel. So ultimately, the H is worth A, which is that length there, multiplied by sine C, whatever that angle is there. Okay, that seems to be okay. So now I know my height. What do I do with the height? Well, I always times it by the base, don't I? If I'm working out the area. So base times A sine C, because that was my height. And of course, base times height divided by 2. All right. I'm just going to tidy it up a little bit, because the way it tends to look in textbooks is this: half A times B, just alphabetically rearranged them, A, B, and then sine C. Okay, that is one version of the formula, and I'm not going to go into anything else apart from that for now. All right, and just leave you with one more thing. Could you work out the area for this triangle? Okay.